In this video, we will discuss the Excel solution for max flow problems. Okay, so given a network with the source and sink nodes and the capacity for each arcs as labels on those arcs in the network, to create the LP model, we first add a return arc from the sink to the source. Okay, and its capacity will be infinity because we don't want to set any limits. Ultimately, we want to maximize the return flow from the sink to the source. Okay. As usual, we will create the LP model for the network. So define one variable per arc. Right? For example, x25 means the flow from 2 to 5. Okay. x61 would be the return flow from the sink to the source. x46 would be the actual flow from 4 to 5, from 4 to 6 through the arc 4, 6. And then we'll have a set of constraints. Right, so first of all, we have the in equals out type of constraint for each node. So whatever is flowing into a node should eventually flow out of it. Right? For example, for node 2, we have 2 incoming arcs, 1, 2, 4, 2. Right? So there are 2 ways for the flow to get into node 2. So the total that goes in should be equal to the total that goes out. Right? It has 2 outgoing arcs from 2 to 5 and 2 to 4. So the total flow out will be x25 plus x24. Right, so eventually it will be 12 plus x12 plus x42, which are the 2 variables associated with the incoming arcs, equals x25 plus x24, which are the total flow, like the sum of the 2 variables associated with the outgoing arcs. Okay. Remember, for each arc, we'll have for each node, we'll have such a constraint. Right. So this is the first type of constraints. The second type of constraints is regarding the capacity. Right. Remember, for max flow problems, the labels on those arcs shows the upper bound on the flow on that arc. Right. In other words, the flow from 5 to 6 cannot exceed 4. Right. So and in this particular example, since we're considering the railroad network, and the capacity is regarding the number of railroad cars, right? So this is saying the number of cars cannot go beyond 4 from 5 to node 6. Okay. Same thing for all the other arcs. For each arc, we'll have one capacity constraint, except for the return arc. So remember, we don't want to limit it, okay? Because we want to maximize the return flow. Okay, and on this part of the spreadsheet, you can see the actual implementation of the LP model. Right? So first, we create the blue cells, storing the X variables. We have the I and J subscripts in column A and B. So this cell, C5, corresponds to X12. This is X43. This is X61, the return flow. Right? And we have the capacity on those arcs in column D. Okay? And here we have the constraints. So we're implementing the constraints using the form in equals out. Right? So first of all, we should have our objective function. So we'll always would like to maximize our return flow. So the objective function is just the return flow, which is x61 or C14, C16, right? And then we'll use the column G, the yellow cells in column G, to implement the flow into each node. Right. For node 1, there's only one incoming arc, which is x61, so it would be C16. Right. For node 2, again, it has 2 incoming arcs, 1 to 2 and 4 to 2. So 1 to 2 is here, x1, 2. So C5, okay, plus 4 to 2 is C13. So it should be C5 plus C13. Okay, similarly for node number 3, we can go from 1 to 3 or 4 to 3. So it'll be C1 to 3, C6, 4 to 3, C14, C6 plus C14. For node 4, so 1, 4, 3, 4, and 2, 4. So 1, 4, C7, 3, 4, and 2, 4. Right. C7, sorry, C7 plus C8 plus C10. For node 5, there's only one way to get to node 5, from 2 to 5, so it would be E equals C9. Okay, then for node 6, there are 3 incoming arcs, so we can go from 3 to 6, 4 to 6, or 5 to 6. So 3 to 6 plus 4 to 6 plus 5 to 6. For the flow out, it's very similar, right? It's just that we're doing the summation over different variables that are associated with the outgoing arcs for each node. Node 1, it will be 1 to 2 plus 1 to 3 plus 1 to 4. For node 2 is 2 to 4 plus 2 to 5. For node 3, 3 to 4, 3 to 6, right? And then for node 4, it would be 4 to 2, 4 to 3, 4 to 6. Right? So 4 to 6, sorry, 4 to 2 and 4 to 3. Right? And node 5 is this, right? 5 to 6. Okay. For node 6, right, it has only one outgoing arc, which is the return arc. So this should be the return flow, right? Okay, so once we have the formulas ready, we can go to the data tab, click on the solver button, and the objective is the orange cell. I want to maximize the return flow. Variable cells are the blue ones. And for the constraints, there are 2 types of constraints. First, the in should be equals the out. In should equal to out. And then we also have the capacity constraint. So remember here, we don't have a constraint for the return flow, right? So actually only selected C5 through C15, those, I guess, 11 cells, right? It should be kept by the capacity. Okay, then we check this box, select simplex LP, and click on solve. Oh, I think I should select C17 instead of D17. Right? And this will be our optimal solution. Essentially, we have a max flow of 15. Okay? And those are the in and outs for each node. These are the actual flow for each arc.